Hello everyone.
Hi everyone.
Sorry about the delay. There was a technical issue again. There is not gonna be a technical issue, and it's not gonna be a meetup unless there is no technical issue. But anyway, we're doing RK again, and today Ken is not in the room, so we are joined by a new co-host, Tiger. Hello, Tiger.
Hi everyone, I'm Tiger. Tiger with the one.
With the
That's
one,
my
yes.
mattermost handle.
Cool. Okay, let's shorten this a little bit because got issue. Okay, so today, before we start the actual event, there was actually an interesting topic happened last week in one of our Rhythmos chat. So there was an interesting issue about Safari, right? So
Yes.
can you tell us what it was about?
Okay, so we got a bug ticket saying that our price on the footer is not updated, and so we look into it. And then we realized that if you update the sticky element content and its position at the same time, the content will be not updated. Shall we just show the
Shall
code?
we go to the code? Yes.
Yeah.
Let's go.
Alright, so to replicate this issue, we have a very simple React component, has a state, and initially the value is null, and then after 1 second after component did mount, we set it to an object. And on the UI side, we show 0 when the initial value is null, and then we show up the full value. But one thing to be noted is that on the UI side, we have a very tall element that only shows up when the value is set, and also a position sticky element that is the sticky footer that has the value, right? So the expected result is when it shows up after 1 second, there is the footer that is originally on the top of the screen will be updated on the bottom since it's sticky, and then the content of the element, the footer, is going to be updated to 1. But in Safari, let's go to the demo. Yeah. So if I refresh, you have a 0, and then the state is updated, but the content here is still 0 until you make a scroll to the bottom, and then there is 1. So
You mentioned the DOM is already
yes.
1.
Yeah. So when I get the reference from the React on the footer element, and I log down the node.inner HTML, it's gonna be 1 in the console, but still 0 on the screen.
Oh.
And when I try to update the style from original style to, let's say, transform, translate 3D 000, and then it's gonna be 1 updated. Yeah. Right when I set the style.
Okay. So before we go into more details of how to replicate this, without revealing our company secret, can you tell us what is the situation and how, what is the situation that we're actually facing this, and how critical it is that it affects our business?
Okay, so the bug tickets is about checkout page, our checkout page.
Right.
Since I'm working on checkout.
Can go to Shopee SG and try a checkout page.
Yes.
Buy something.
Yes. Okay, if you're trying to check out for more than one item, it's likely that your page is gonna be like taller than 1 fold, right? And then our footer that has the place order button and the total price, the subtotal, is gonna be updated to basically it's a sticky element. And it's gonna be like a sticky to the screen on the bottom. And then we only show the shop orders when after we fetch the data, right? And also the subtotal. So the bug ticket says when we show the items, the price is not there. It's still 0.
Oh.
Yes.
Displaying the price.
So it looks like you are buying stuff for free, but actually it's not.
Oh, that is important.
Yes.
We're gonna lose a lot of money if people are checking out with zeros.
No, we don't lose money actually, but we might get complaints like,
Alright.
yeah, I'm buying free stuff, why do you charge me?
Alright, okay. Yeah. Okay. So how do we replicate this to be precise? I know we can replicate this one here
Yes.
on my machine.
So yeah, there are actually a couple of criteria that you need to hit before you replicate the bug. Firstly, set timeout is very important. I'm putting set timeout here is to simulate a response to API response, like HTTP API response.
Okay.
It's kind of like we fire up an API call and then we get a response and then we update the DOM. This is to simulate that. But if, let's say, we remove the set timeout here, it will be updated as expected.
Oh.
Yes, the bug is gone. Another thing is, if let's say the very tall element is always there, then that sticky element's content is going to be updated. The bug is gone. So this bug only happens when you put a very tall element at the same time when you update the content, and then the content will be like stale, not updated. Yes.
Oh, okay.
Yes.
It's quite a complex situation.
Yes. So based on that, our fix is to basically put a callback for component did update, and then realize, oh, it's updated, then we should set a special style to the footer element, basically setting transform, translate 3D 000, just to let the content flush in.
Oh, I wonder how our PM found out about this.
No, it's QA.
Oh, right, yeah. Oh, okay.
Yeah, actually the bug has been there for like, I don't know, at least half a year.
Oh, wow, okay.
Yeah.
So it sounds like a browser bug for me. Is there anything we can do to help to get this fixed?
Yes, I'm trying to file a WebKit bug ticket, but still I'm trying very hard to remove rec from the story. But so far I haven't managed to do that because my vanilla.js version of this demo does not replicate the bug. I'm
so
still
normal?
Yeah, so it's normal. So I'm still trying to see how rec.dom actually respond to this set state and update the DOM and write a vanilla.js equivalent of this demo.
Okay.
Yeah, I'm still trying that.
Then are we sure that it's not a React issue?
We're not sure yet.
Oh, okay.
Yeah.
I see. Interesting.
But still, when I get the reference on this footer, the DOM reference, and try to debug it in the console, the HTML content, the inner HTML is already 1, but on the screen it's still 0.
Oh, okay.
Yeah.
So we might actually post this, broadcast this bug, and we're not sure where this is going yet.
Yeah.
Okay. Alright, cool. Thanks for sharing this. This is really interesting. Arcade love this kind of exploration. Okay, so I think we are ice broken. So let's start our actual event for now. Please stay with us. Okay, so today we're doing Arcade week number 66. It's a big number. Today we will, so different from previous week, this will be the first time we actually adapt remote speakers. So for those of you in the room, in our meeting room, watching, you can see that I am not in the room, so we can play Guess Where I Am game, and our speakers are also in mysterious places in this world, but they are calling in. So Huijing will be calling in. Okay, I'll try to not spread fake news. Huijing is calling in from Kiev. She was originally supposed to be calling in from Munich, but thanks to COVID, Munich cancelled. Yeah, and actually COVID is how we started doing the broadcasting anyway.
Yeah.
And then, depending on whether our second speaker will be able to make it, his company does not have public Wi-Fi. We do not know where he works, but okay, let's see. So, like always, you can find the GitHub issue link with the link here, and you will find all the links that we share later on in reference to the talks. We are broadcasting from the beautiful office of Shopee. Our live streaming graciously supported by engineer SG, and our second speaker, if he shows up, he will be calling in the original plan. Will be calling in from Hackerspace, also supporting a lot of our local meetups. So shouting out to all of them. We do have a COC, so do not record our live streaming. Do not post advertisements in the live chats. The live chats is quite quite interesting. I'm looking forward to checking once we pass to the speaker. And also do not speak mean things to each other. Just be nice in the live chat. We are welcoming speakers now officially from all over the world. So our next open slot it's kind of scary. It's in 2 weeks, and then after March 27, it's kind of booked up until quite some time. So if you have something to share, March 27 is up for grab. And yeah, and then speaking of upcoming events, we will have a Shopee and Carousel joint sharing session coming up pretty soon.
Yay!
So if you're working at Shopee and Carousel, you should already hear about this. We will pick a theme. Then each of us are going to share something that we learned from our work and do a joint event. This is expecting to happen early April, so stay tuned. Then more meetups are going live stream. The world is not doing well with COVID. So Junior Dev SG Code and Tell happening right after today's arcade. So you might not have booked your place yet, but you can watch the event live. I created a bit.ly link for them also. Took the liberty of doing this. So yeah, definitely check them out. You don't even need to move. You can just go to a different link and then you can watch the live stream already. So our first speaker will be Huijing. Huijing, she's, like I mentioned, she is currently in Kyiv. She has designed our stickers. So all arcade stickers, including the one you're seeing on the screen, is designed by Huijing. Her most recent work is the Year of the Mouse limited edition speaker sticker.
Very nice sticker.
Yeah, I know, right? Our speaker last week, he already got one. And
yeah, it's very cool. Thanks, Huijing.
I think we can show this here by grabbing your laptop. So, wait, it looks like this. Upside down.
Yeah. Yay.
Yay. Oh, never mind. I'm being really bad at this. So Huijing designed our speaker, so she must get one. How does she get one? She will need to speak. So okay. I think Huijing should be in the room, although I'm not seeing her on the right. So Huijing, can you share your screen? Once I see your screen, I will pass it to you. Hello.
Looks like her Wi-Fi is.
Hello, Huijing, are you here? Okay, sorry about this. Okay. Sorry about this. So it will be now passing on to your talk. So if you can start sharing your screen, it should show up on our side pretty soon. Okay, got it. So let me pass it over to you.
Oh my god, wait. I lost my own slides. Now, okay. So do you see the amazing cover of what is this?
Yes, I do see this.
Okay, wait. So zoom no lag. Okay.
let's go.
Yeah. So what is this? This is like this is like everybody's favorite question. This is like, what is the meaning of life? So okay, let's move on. This is my first slide. Yes. So we must first ask ourselves, where did the concept of this come from? This is a very important concept of object-oriented programming. Okay, so the first object-oriented programming language is called Simula6. Simulation language. Last time people are very smart, know how to name things. They just take two words and then they cut the front and then you get a new name. Can take this as a tip. Simula 67 is like the second edition of it's supposed to do like simulation scenarios one. So this was back in like I assume it's like 60s because that's why it's 67. But Simula 67 so it kind of introduced these OOP concepts or like classes, class inheritance, etc. But the actual term, right, of OOP was coined by Alan Kay, who is the guy who created Smalltalk. Smalltalk is actually not. It's like everyone talks about Smalltalk like is a functional programming language, yes. But the point is, and I will talk about the point later. The fact is that the main concept, like the main idea Alan Kay come up with for OOP is that he wants the software to be like behave like encapsulated mini computer. So you communicate via message passing as opposed to direct data sharing. That was his original idea. And Smalltalk, like I said, is a FP, is a functional language that's inspired by Lisp and the earlier Simula. So now the key essence of OOP, according to Alan Kay, I think it has since like changed. Like everyone has their own definition of OOP nowadays, but like the guy who created the term, right? There are three main points: is to avoid shared mutable state by encapsulating and isolating objects from other local state changes. Second one is to decouple objects from each other. And the third one is to be adaptable and resilient to changes at runtime via late binding. So that's the three things: message passing, encapsulation, and dynamic binding. Then Simula also introduced the ability of an object to reference itself using this. So that was a very long-winded way of trying to explain like first instance of this in OOP. Maybe if someone can find a more accurate history, can update. So I mentioned dynamic binding. Since it's dynamic binding. Dynamic binding is the process of determining the method to invoke at runtime rather than compile time. So static binding is compile time, dynamic binding is runtime. So what is binding, right? Binding is the association of a symbol within a program to the address in memory. And because of this dynamic binding, right, it depends on your scope rules. So usually, but maybe not all the time, local variables are bound at runtime and global variables, you do it at compile time. But in OOP, the issue is that an object can respond to the same message with a different implementation. So in order to kind of like mitigate this race condition, you use dynamic binding so you can determine which method to invoke during runtime. So is JavaScript OOP? Well, we can examine the behavior of JavaScript. JavaScript can and does support encapsulation, message passing, behavior sharing, and all those other things that make OOP OOP. With JavaScript, you can also assign any function to any property. Okay. With JavaScript, you can also like build object behaviors dynamically. You can change meaning of object at runtime. You can do encapsulation using closures for like privacy. So that's like the hack for private variables. But just because your language use object don't mean your code is object oriented. Just like you program with function, don't make your code functional. This is I thought this was a very salient point. So JavaScript is actually a multi-paradigm language that it supports the object oriented style of programming, and you can also do dynamic binding. But objects in JavaScript, they are simply composite data types. They don't have any of the class-based programming or message passing that the LNK was so like on about. So yeah, that's the summary. Yeah, just because your JavaScript got everything is object domain is OOP lah. Moving on. So this in JavaScript, so a lot of languages got this. Like almost every language under the sun got this lah. Some call it self. Some call it I don't even know what V. There was another one VB called it something else lah. But basically it's either this or self, right? So the JavaScript version, right, uses the prototype chain. And for JavaScript, it's really it's about where the function was invoked and not where it was declared. I think this is like the 重点, the main point, right? So the meaning of this inside a method is determined at runtime. And so you should be able to using this, right, it lets you decide what object should be focal when you invoke the function or the method. Yeah. And moving on. So long ago, before year 6, before error functions, some of you might have done this, and some of you might think, wow, Simi, like, why write this kind of funny code? But like last time when I start, there was this let's call this a code pattern called var this equal that. Why var this equals that? Because okay, you look at this very simple example about animals and pandas, right? The one on the left is the version that doesn't work. So if you copy and paste this code, and then every second you look at your console log, right? Your panda, wait, is it panda? Yeah, your panda forever 0, forever never go old, like immortal panda like that. But if you use the var that equals this, your panda starts to age. So because even though, right, the animal constructor define, Chia is here. Hi, okay, never mind. Hi, Chia. Connecting the audio, Chia cannot hear. Anyway, even though the animal constructor define this as an instance of itself, you use non-strict mode, the grow up function, it defines this as the global object because that's where it's being executed. So it's not, again, it's not about where it's declared, it's about where it's being executed, right? So essentially, they are using different this. So when you assign this to a variable called that, I think assign to that is just people like GL or their own self want to put like be funny. You can actually assign it to anything else. So you can say like variable dinosaur equal this also can, but like people like to use that, so it become var this equal that. So when you do var this var that equal this, it will smuggle the outer value of this into the inner grow up function via the that variable. Oh, can't believe I just said that. So nonsense. Moving on. So how can you tell what this is, right? So there are a number of ways, depending on, there's also like many different types of binding in JavaScript. First one is implicit binding. So this quite straightforward lah. So implicit binding. So when you have this type of like methods, right? You invoke it with a dot. So you want to know where what this is, right? You look to the left of the dot. So left of the dot usually is the context, and this is like, I think apparently this is like 80% it should be true lah. So you look at this very funny function, grid method, right? You look, the first one say on the left is who? Animal. So the context is animal. If you look at the second one, right? Look at the left, who? Family. So the context is family. So the first and the first one is I am a panda. Then the second one is I belong to whatever family. That's how implicit binding works. Okay, moving on. Next. Then you have explicit binding. So explicit binding is when you use call, apply, or bind. We talk about call and apply first, bind later got extra. So if your function stand alone, like it's not the method of an object, you can still invoke the function and declare like where you want it to be by putting that context into the parentheses, which is the parameter. So the difference between call and apply is so like if you want to put additional parameters in addition to the context, you just add to the back. Then when you use call, right, like each individual one is an extra parameter. If you use apply, right, you just shove all of the parameters into an array. So I guess it looks neater. Okay, never mind, moving on. Okay, also use new. New. So basically when you use the new keyword, JavaScript will create a new object called this for you. So this will delegate the animal's prototype on failed lookup. So cause like, this for JavaScript relies on, it's a prototypal inheritance, right? Cause JavaScript does that. So a delegate prototype is the object that serves as a base for another object. So when you inherit from a delegate prototype, the new object get reference to the prototype. So if you try to access a property on the new object, you will check your own property first, yes. Then you cannot find it, you go up, you keep going up until you hit object.prototype, which is like the root base topmost whatever. Moving on. Lexical binding for all the like young kids who started doing JavaScript when ES6 came around, and then it start already use arrow function. Hiya, so nice. But arrow functions don't have their own this. So because I think everybody confused with capital K, confused about what this is. I think when the TC39 people go and write spec, okay, let's just make this behave like most people expect it to be. So lexical binding, right? JavaScript just look at the enclosing parent scope like by default. Like you don't have to think very hard. JavaScript engine do it for you. That's lexical binding. And then I also got window binding. So basically, if you're using strict mode, and actually by rights everybody should use strict mode lah, undefined window, it will be undefined if you use strict mode like this in these examples, right? And you just say return this, then you never declare, right? It will return this. Is the left side is non-strict mode, then the right side is strict mode. Non-strict mode in the browser, it will tell you return you window, the window object. Then if you use node, there is no browser, then it will tell you global. But if you use strict mode, right, it will tell you undefined. You will not own self anyhowly go and assign this to something. So for in the grand scale of things, I think might be less buggy if you use strict mode lah. Cause then it's more it's more predictable. Yeah. Okay. Okay, so explicit binding part 2 means I talk about bind. Why bind? Because this is the part where it's slightly more relevant to your React children. Okay, anyway, so bind is exactly the same as call, but instead of you invoking the function immediately, you return you a new function, then you can call it at a later time. Yeah, so that's why it's called bind. So the new functions, this keyword here, in this example, is set to the provided value. So for this particular example, your panda will grow up. It will not be immortal. So like I said, this is React knowledgeable. React di mana? Okay, so we need to talk about event handling law. Okay, so for example, this is a very common and simple, straightforward example with regards to on-click event. So when you write it in JSX, it's like the curly brace. JSX pass the event handler as a function. But if you don't write React, then you just use vanilla JavaScript. When you do the on-click, right, it passes as a string because HTML passes, all HTML attributes are strings. So the value of the attribute is copied to the DOM object that represents the element. So when you access the attribute value using JavaScript, you'll get the value set in HTML. And when the code is called from the inline on event handler, this is set to the DOM element where the listener was placed. So this is called inline JavaScript, right? If you use JSX, class methods are not bound by default in JavaScript. I think we already explained earlier. So when your handle click function pass to on click, you're passing a reference to the function. So when React call the function, the context of this lost now. So get-code undefined. Get-code means end up undefined. So okay, that's it. Moving on. So to make sure this works right, in React, I think the earliest method is let's say traditional method is you must bind this law. So you must, if you look at the left side example, there's this dot handle click, then you must bind this to this to make sure that this is correct. Apparently, people don't like to write bind this. Apparently, again, okay lor, right lah. I don't have like extreme opinions about this, but apparently some people don't like it's so icky, don't like write bind. So never mind. Now got arrow function. Then you write on the right side. As you can see from the code block, is even shorter. Then font size can be bigger. So when you use error functions, because we explained about how lexical scoping works, you don't have to write the bind explicitly. Write the bind. This also can. So the third option is you can use the hook things that everybody loves so much. This amount of code. Because if you use hooks, can you see the word this anywhere in this example? Don't have. You don't have to think about this because you're not using it. Okay, moving on. Okay, so this is a bunch of articles about binding, blah, blah, blah. This was in case Chia is late, but Chia is here. So we don't have to talk about it. We can just see the effect. So basically, I'm very upset that there's no red panda emoji. The closest thing we have is a trash panda. So what we do, we use CSS to make a trash panda red. But like, my wise friend once said, all animals are pandas, just vary by color. So like just change color, then you got like new species. Wow, amazing. Oh, someone, okay. This is in case Chia still never show up, but we can just skip this. So yeah, that's it. Okay, thanks, bye. Chia, you're up. I will stop sharing now. Hi, Chia.
Hello. I'm here.
Hi. Oh wow.
Yay.
Cool. No, everybody's in the
Do I
room.
start sharing now?
Yes, okay, bruh.
Okay.
Okay, wait. I think I did not have.
Okay.
I'm not going to shut up. I'm just going to make snarky comments about your monads.
Nice. Okay.
Okay,
let's
can everyone
switch
see my
over.
screen? Well, actually, that's not the appropriate thing to ask.
Why not?
Okay, I'll just assume because nobody can reply.
They can type in a live chat.
Oh, okay, never mind. I'll just assume it's okay. Okay, so hi everyone. I am Chia, as you all know. And today is my attempt to I wouldn't even call it explain, just maybe share my confusion about this thing called monads. So I don't have many slides. I mean, I don't have any slides, but what I do have is some code. So I'm going to do my best to explain whilst live coding, which hopefully won't make things harder. All right. So before like trying to explain exactly what a monad is, let me describe one of the problems that that monads can be used to solve. So in JavaScript, we often in JavaScript, you know that you cannot do things like access the property of undefined or access the property of null, right? So typically what we do is we write a lot of code that does this checking. And if you have if you imagine you're like making an API call and then you get back some result and then you transform the result here and there, there are a lot of places where things could go wrong. So one of the things that the monad pattern can help you do is encapsulate some certain behavior, so that instead of passing around a value which may or may not be the value you expect, you pass around a thing which lets you act as if the value is there, regardless of whether it's there or not. And today I will refer to this as the option monad. So I will explore the features of monads using this option monad as the example. And in order to do that, and I'm going to do it in JavaScript, even though JavaScript doesn't actually really support this. So there are going to be a few times where things like don't really look right and may not make sense, but I'll try my best. All right. So the first thing to know about an option monad is that based on the problem I described, you either have a value or you don't have the value. And what you're trying to protect against is doing things to a value, expecting that it's there, but actually it's not there. So an option can be either nothing, which represents like null or undefined, or it can be some. And I've chosen here to represent these as subclasses of this very thin class called an option. So so if let's say we're working with integers, and I want to do like 3. Oops. Okay. Okay, we will do that later. So the first thing that you need to have in a monad is you need to have a way to to the thing that you put inside it. So let's say let's say we're working with numbers, and we want to be able to do something like multiply the numbers. So let's say we write a function and it doubles a number. So hang on, why is this not working?
Are you in the correct folder?
Yeah.
Okay. Cause your error is cannot find module.
Yeah. Okay. Sorry, bear with me one moment.
Turn it on and off again, yo.
Okay. How should we do this?
Right, how you Google the error? Ni Hao say there's a space in front of the file name. Oh, your new. Yeah, yeah.
Oh,
Wow, his sharp eye there, I can see it.
Wow, you can see empty space.
Yeah, sia. Walao eh. Win.
Okay,
Winner.
okay, so time is short. So let me do what I wanted to do just now. Let's say we have a number, right? 3 and we have when we wrap it in a monad, it looks like this, some value 3. So in this case, we know that it's there, okay? But in general, at some point, we should be able to operate on this as if it's not there. So if I want to double 3, I obviously cannot. I cannot do something like this. I cannot do this. That's not going to give me what I want. That's going to give me not a number. So what I need to do is I need to add a way for me to call this function with the inner value. And I will call this map. So what I'll do is I'll pass map. I'll pass the function to map. And if my option is not none, that means it's sum. Then I will call this function with the value, which is 3 in this case. And what I'll do is I will return that wrapped as well. So if it's not, I will just return nothing. So now we can do something like this. And when we run this, we get 6 inside the monad. So we've doubled it, right? We've kind of kept the bits around the 6, but managed to double the thing inside. from 3 to 6. All right, so this is fine, but this only works for functions with so let's say I have a function called multiply, and it takes 2 arguments like this, x, y. Now the first thing is that for reasons in functional programming, of which monads are part of, there's no such thing as a function with 2 arguments. Reasons I won't go into now, but basically you have to make it you have to curry it, which means that you will do something like this in order to multiply the 2. So if we do that, then let's try passing multiply into map. So I'm going to call multiply, right, with one argument with the first function, according to my definition here. And what I'm going to get back is a optional function, right? So I've gone from an optional number to an optional function, and now I have a problem because I've given the x, but I still need to pass the y, and I now have no way to pass the y, right? So let's see if I do this. So I cannot do this, right? That time the error is expected. So I need something else. I need another I need another method in here which will help me to deal with cases when I have functions that have more than one argument, which to be honest is quite common, right? These things wouldn't be very helpful if they only were able to operate on functions that have one argument. So this is where another method comes in, and I'm going to call this apply. So apply takes a argument, and this argument is an optional function. That's why I call it OF. So what apply does is it says if OF okay, I cannot call it OF. I'll just call it G.
Off is reserve, I think.
Yeah.
Yeah.
So if G is because G is an optional function, right? So we first have to check if it's actually there or not, which means it's an instance of sum. If it's there, then what we can do is we can take the actual function itself, which is the dot value, and then call it with this dot value. Again, if there's nothing inside, then we just return nothing. So let's try that. So we have A, and then what we'll do is to apply A. So we get 6, right? So we've got the 3 and the 2 here, and they've somehow managed to multiply each other, and we've got 6. But there's a problem, which is that we've returned the actual 6 value, but that's not very helpful, because if I have a function like this, which has 3 arguments. Let's see why. Right. And
Good name,
let's
sir. Good
say,
name.
so let's say I do a crazy multiply with 3. So 3 has gone into x, and then 2 has gone into y. Right, let's see what I get here.
Crazy multiply, right? You trying to say?
Oh yeah, sorry. So I get a function, which is fine. So if I say 3 again, oops. That works, but it's not supposed to.
Was supposed to error, right?
Wait,
Like,
I need to,
look
no,
of
I need to
surprise.
remember why that's not helpful. Oh yeah, okay. Because you cannot you cannot just call. The whole point is that we don't want to assume that we can just call 3 here, right? Because the point of all this is that things might become nothing at some point. So this works here because everything is good. But if along the way, right, something bad
is
happened,
not,
and
yes,
yeah,
something is
we end
now,
up we end up here instead. And in a nothing, you cannot just call nothing, right? You cannot call nothing assuming that it was giving you this instead.
You can't
right?
simulate
And
nothing, right?
yeah. So
Okay.
so this you may be like halfway through your big transformation of your API response. So what you want to do is you want to keep applying and mapping and doing stuff, which you cannot do here. So in order to fix that, what we do is we just return this wrapped in as an optional. So when we call this, what we get is we get back another optional function. And why do we want that? It's because we already know how to deal with optional functions. We already have a method called apply, which helps us to deal with optional functions. So after you've mapped and applied, you can actually just keep applying. No matter how many arguments you have here, you can just keep applying, and it will work. So those that's map and apply, and I think we have like, do we have all the way until 7 p.m.? Because okay, I'll take that as a yes.
Yeah, okay. Silence means consent. Lol.
So in functional programming, apparently it's not very common to actually have functions that like take an integer and then return take a type and return the same type. It's apparently sufficiently common that you have functions which are something like this, something like that. So they take in something like an integer, but they return an option. And so apparently this is very common, and that means that between map and apply, we cannot we cannot deal with that. So let's say we have a function called try-half, and if the number that we give it is divisible by 2, is not divisible by 2, then we return nothing. Otherwise, we return half of that.
Do you need
half
to
of that number.
zero? Do you need to zero your condition?
So this means if it's not divisible by 2, right? That means this will be, what you mean, like this?
Yeah, don't need, huh?
I'm trying to do the opposite. I'm trying to do the opposite though.
Oh, I see. Okay.
So this is a function which takes in an integer but then returns basically an option, which is an option being sum or nothing. So if we try and map this, let's see. We get an option with another option as the value, right? So it's like a nested option, which is not, basically, cut long story short, is not helpful for us. So what we need is a way to deal with functions like this, and I'm gonna call this method chain. And again, this is gonna take a function, and wait, I need to just cheat. Okay. So again, if we are nothing, then, or rather, if we are something, then what we can do is we just return h discount value. So it's really similar to map. It's just that we are not wrapping it in an option, right? So if we do that, we have nothing, right? Because 3 doesn't divide by 2. However, if we put 4 in, then we have sum 2,
nice.
which is what we want. And now we can keep adding things onto this, right? And it doesn't matter if at any point we get nothing. We have a way to add more functions on, right? So we could then map double here. So 4
nice.
half, and then half is doubled again, so we get 4. But if we have 3, then like we get back nothing, but that's an expected value, and nothing is broken halfway. We just pass through. So after we go, after we reach try half, it returns a nothing. Then our implementation of option allows us to keep mapping, even though there's a nothing in there.
Okay, so like you can indefinitely chain stuff. That's what you're trying to say.
Yeah,
right?
exactly.
Nice.
Yeah, you can indefinitely change stuff.
Cool.
So to end this, I wasn't going to do this last part, but I think the audience is.
Apparently the host has said if they need to go home, they can continue watching on the bus on their phones, so it can keep going.
Okay.
No problem.
Okay. Well, from my perspective, there's only like 3 of us here, so that's okay.
Lol.
All right. So so the last thing I'll do is I will just touch on the monadic laws, okay,
Nice.
which is how you like mathematically determine if something is a monad or not. And I will, so they're actually, like, this is a very interesting topic, but I'll just touch on the 3 main ones. But before I do that, I have to remind myself what they are. There's left identity, which is basically that okay, so sum to dot chain double, and double to wait. So if you take a number and you wrap it, and then you chain a particular function, it should give you the same result as just
the function itself.
Chaining, just calling that function on the number itself. So basically these 2 should give you the same result. So that's left identity. Right identity is, I forgot. New sum. Oh yeah, okay. Okay, so slight detour, okay, 30 seconds detour. For reasons which I won't go into now, instead of always doing new sum to, we are apparently going to provide a way to get an option from a number. So something like this: return new. So instead of doing new sum to, right? I can do sum dot return
okay.
to. Yeah. Okay. So yeah, like I say, won't go into it now. But right identity states that if you have something and then you chain you chain this, then it should be the same as I think it's just the same as this. Oops,
what's option?
clearly not. Yeah, option is this.
Oh, okay. How come? Oh,
Sorry, typo.
yeah.
So okay.
Yeah.
So right identity states that if you chain the special function return on an option, then it's just the same as the option. So your implementation of chain needs to correctly use the return.
Okay.
So that's right identity. And then the last one is associativity, which is basically that if you do something like this, where you do the chain, okay. Okay, wait. I have to choose two different functions. Let's see. Try add one. So for argument's sake, I like this doesn't actually return a nothing, but the main point is that it returns an option. So some will do. Let's imagine that this thing might fail in certain cases, right? So it might return a nothing. So if we do this, we have this, which is 7, which is 4 plus 3. Yeah, it should be. So what we're doing is we are calling try half first, then try add 3. We should be able to compose try half and try 3 into one function, and then put it in a single chain.
Okay. So even if you do that, you're saying that okay.
We should still get
I think
some 7.
associative feels very like maths. Okay, anyway, continue.
Yeah. So it's a little difficult because normally if you have if you have normal functions, sorry, not normal. If you have functions like double and multiply, you can compose them just by calling them and then passing the result to the next one. So you'll do something, like double,
then try half, then and so on and so forth.
So this is normal sort of composition, right? Which will be 12. But we cannot do that with the kinds of functions that chain expects, right? Because when we do this, we get back an option, right? But try half doesn't expect an option. Try half expects a number. Right? So we cannot compose it exactly like that. So you have to do it something like this. you have to do, let's see, try half x. You have to do this. There's apparently a special way of composing monadic functions called Kleilsey composition, which is what this is.
Okay.
So anyway, if you do this,
I think, yeah, must go up, yeah.
if you do this, then you should also get 7. So that's the law of associativity. If you chain two functions, if you chain twice, you should get the same as if you compose those two functions and chain once.
Okay.
So I am like 8 minutes over time, or possibly 30 minutes over time.
Lol.
So that's it. I don't have. I have a few resources that were interesting to me, which I basically just repurposed into this. So I'll put those in a slide, and then people can take time to go and read. But that's basically it. So what monads let you do is they help you abstract away certain handling of certain situations. So an optional monad is just one example,
Yeah, it is.
which helps you deal with values which may or may not be there. But there are other monads as well in functional programming languages to do with like asynchronous values. Even a list is technically a monad, as long as it implements these methods. Then it and it satisfies the laws, then it's considered a monad, right? So you don't have to, you don't necessarily have to chain options all the way. You can actually chain like different things. So try half returns an option, but try add 3 might return a different kind of monad, like an async monad. So if try add 3 was like an asynchronous function, it might return something like this, right? But you can still keep doing dot chain because they all have chain. All monads are the same, and yeah, that's it. I'm done.
Nice.
Wow, thank you for.
So what happens now?
Are we?
No, I don't think so.
Ask the boss. The boss is like mysteriously muted. Like,
Yeah,
so
no.
we don't know what she's. It's like a conversation between you and I, because I have no idea what's going on on the other side.
No, we're not muted from the live stream.
Yeah. Okay.
We're
It's still
sorry.
Okay, she's back.
No, we're not muted on the live stream. We're only muted in the con call. So to avoid echo, I'm gonna mute myself. Yeah, I'm gonna mute myself again. Okay, so right way is this.
Okay.
But you didn't tell us what we wanted to share.
Yeah. Yeah, I know, right? You can type it lah. You type it. I'll just continue talking to Chia to like the space.
Okay.
I think maybe. No, I think like we are like hanging out with each other, and then she's doing her live stream shit.
Wait, no.
You stay in office. This is your meeting room,
Sorry about this.
Not
Anyway,
my
so let's wrap up this event
Yeah.
first.
Okay.
Thank you both
It's just
for
a meeting
the
room.
talk. That almost sound like one talk in 2 parts.
So you Changi Business
Although
Park.
we never coordinated
DBF
the
office.
contents.
Okay. Cool.
Great collaboration, great streaming, guys. And we can see you here, Chia. Yeah, so I will somehow pass you the sticker when I see you next time. If I don't see you in a long while, I'll try to mail to you the awesome stickers. Then so
stickers
once
not
again,
perishable.
we are
sticker is like
looking
keep it.
for
cannot contract COVID.
Alright, so we're looking for speakers. Please poke us if you have a topic for share, and we are we are calling this. Please enjoy your Friday night, and I'll see you soon.
See you next week.
Okay, bye.
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 And